Want to build powerful AI agents but not sure which tools to use? Artificial intelligence is no longer limited to answering questions or just generating content. Today, AI systems can plan tasks, make decisions, use tools, and even collaborate with humans to achieve complex goals. This new evolution is called Agentic AI, and it is rapidly transforming how businesses operate, how software is built, and how work gets done. In this course, you will learn what Agentic AI really means, how AI agents think and act, the technologies behind them, and how they are applied in real-world scenarios across the industries. We will move step by step from foundational concepts to practical understanding. So, if you're a beginner or a professional, you will gain clear and actionable knowledge. So that said, let's go through the agenda for today's session. First, we will have an introduction to Agentic AI. Then we will dive into core concepts of Agentic AI. Then we will have Agentic AI frameworks and libraries. Then we will dive into memory and long-term context. After that, we will enter into planning and decision change. Later, we will understand advanced use cases of Agentic AI. Then we have agent evaluation and prompt optimization. Later, we have risks, ethics, and future of Agentic AI. And then comes the last part where we will have hands-on project on Agentic AI. I hope I made myself clear with the agenda. And by the end of this course, you will not just understand Agentic AI, you will understand why it is considered the future of intelligent automation. So let's get started. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons along with the bell so that you get notified whenever we host. Also, just that you know, if you want to upskill yourself, master generative AI and artificial intelligence skills, and land in your dream job or grow in your career, then you must explore Simplilearn's cohort of various generative AI courses and certifications. Simplilearn offers various certification programs in collaboration with some of the world's leading universities. Through our courses, you will gain knowledge and work-ready expertise in skills like advanced Python, machine learning, generative AI, and over a dozen others. That's not all. You also get the opportunity to work on multiple projects and learn from industry experts working in top-tier data and product companies. And after completing these courses, thousands of learners have transitioned into an AI and machine learning role as a fresher or moved on to a higher-paying job and profile. If you are passionate about making your career in this field, then make sure to check out the link in the pinned comment and description box below. Now, before we begin with the course, here's a small quiz for you. What is the main characteristic that differentiates Agentic AI from traditional AI? So your options are A. Faster computation speed, B. Ability to act autonomously towards goals, C. Larger datasets, and D. Better graphics processing. Please do let us know your answers in the comment section below. Now, let's get started. Welcome to this course on Agentic AI. In this first chapter, we are going to build a clear foundation by understanding what Agentic AI is, how it evolved, and why it is becoming one of the most important advancements in artificial intelligence today. Let's begin with the most important question. What is Agentic AI? Agentic AI refers to artificial intelligence systems that can act independently to achieve a goal instead of simply responding to individual instructions. In traditional AI systems, the interaction is very simple. You give an input and the system produces an output. This is called request-response model. It introduces goal-driven behavior, decision-making ability, and the use of external tools and iterate reasoning where the system can evaluate and improve its own results. A simple way to understand this is large language models generate content. Agentic AI performs tasks. Agentic systems combine language models with planning, memory, and tools so they can complete complex workflows with minimal human intervention. For example, instead of asking an AI to write an email, an AI agent could analyze the situation, collect the required information, draft a message, and even send it automatically. This shift represents a major transition in AI from passive intelligence to actionable intelligence. Now, let us understand how we reached this stage. The evolution towards Agentic AI happened in three major phases. So the phase 1. Phase 1 was traditional AI systems. These systems were mostly rule-based or trained for very specific tasks like image classification, fraud detection, or recommendation engines. They were powerful but limited because they required predefined logic and could not adapt easily. Now, the second phase introduced large language models, or often called as LLMs, and these models brought major improvements in reasoning, conversation, and content generation. They allowed AI to interact in much more natural way with humans. However, LLMs still had important limitations. They did not have persistent memory, they could not independently execute decisions, and their interaction with external tools was limited. The third phase is the important one. The third phase is agentic AI. Here, language models are combined with planning systems, memory mechanisms, tool integrations, and execution loops. This allowed AI systems to operate continuously towards a defined objective, similar to how a human assistant would work. Now, let's talk about why agentic AI matters. AI is important because it enables automation of thinking, not just automation of physical or repetitive work. There are three major areas of impact. The first is automation of reasoning. AI agents can break problems into steps, evaluate results, and adjust their approach without constant human supervision. The second is automation of tools. AI agents can interact with APIs, databases, software platforms, and external applications. This turns AI from a simple chat interface into a system that actually performs operations. The third is automation of tasks. Complex workflows like market research, report creation, data analysis, customer support, or even software development assistance can now be partially or fully automated. From a business and economic perspective, many experts consider agentic AI to be the next major productivity leap after cloud computing and mobile technology. Now, let's take a look at the key characteristics of agentic systems. Most agentic AI solutions include five components. Goal definition. Understanding what needs to be achieved is the important one. Second one, planning and deciding how to achieve the objective. Third is execution, performing actions using tools or systems. Fourth is memory, storing information from previous steps. And the fifth is feedback loop, which is about evaluating results and improving performance. Interestingly, this structure closely resembles how humans solve problems in real life. Let's also take a look at some real world examples. We are already seeing early adoption of agentic AI in areas such as autonomous research assistants, AI coding tools that can debug and deploy applications, personal productivity assistants, multi-agent business automation platforms, and workflow orchestration systems. Organizations are actively experimenting with these technologies to improve efficiency and reduce operational costs. Now that we have a strong understanding of what agentic AI is and how it evolved and why it is transforming industries, we are now ready to move to the next chapter. In the upcoming section, we will explore the core concepts and architecture that make agentic AI systems work behind the scenes. Now we enter into the chapter 2, which is about core concepts of agentic AI. In the previous chapter, we introduced the idea of agentic AI and why it represents the next evolution of artificial intelligence. Now, in this chapter, we are going to go a little bit deeper into the core concepts that actually make agentic AI different from everything that came before. And this is very important because before you build intelligent agents, you must understand how they think, how they operate, and what makes them autonomous. So let's start with the big picture. Traditional AI versus the large language models versus agentic AI. Artificial intelligence has evolved through three major stages. The stage is what we call traditional AI. These systems were designed to perform specific tasks using predefined rules or trained models. For example, spam detection systems, recommendation engines, or image recognition tools. They work well within a limited scope, but they have some clear limitations. They don't reason beyond what they were trained on. They don't make independent decisions, and they don't adapt when the context changes. In simple terms, traditional AI is narrow and task specific. Then came the second stage, large language models or LLMs. This was a major breakthrough. LLMs can understand natural language, generate content, and answer complex questions, and even simulate reasoning. They were trained on massive datasets by organizations like OpenAI, Google DeepMind, and Meta. But even with all this power, LLMs still operate in simple workflow, prompt to response to stop. You ask something, they respond, and the interaction ends there. They don't independently execute tasks and they don't manage goals over time. So while LLMs are intelligent, they are still reactive systems. Now comes the third stage, Agentic AI. Agentic AI extends LLMs to goal-driven intelligence systems. Instead of generating responses, AI agents can plan actions, use tools, store memory, evaluate results, and continuously improve. Here, even the workflow changes completely. You write a prompt, response to plan, you get an action, you observe, improve, and repeat. This loop is what creates autonomy. Autonomy is prompt-based. Now let's understand autonomy. It is more like prompt-based versus goal-oriented systems. One of the most important concepts in agentic AI is autonomy. Traditional prompt-based systems depend entirely on human instructions. For example, you might say, write me a report or summarize this document for me. The system completes the task and stops there. There is no initiative, no persistence, no independent thinking. But agentic AI systems operate differently. They work based on goals, not just instructions. For example, imagine giving an AI agent the objective to prepare a competitor analysis report. The agent might automatically search for data, analyze trends, generate insights, and create a final document all with minimal or no human intervention. This represents a huge shift in AI evolution. We move on from command-based AI to objective-driven AI, planning in AI. Now, the next one is planning in agentic AI. Now, let's talk about planning. Planning is the ability of an agentic AI to figure out what steps are required, in what order, and which tools to use. This might involve breaking a complex task into smaller subtasks, reasoning step by step, and executing them subsequently. Planning is what allows AI agents to solve problems that cannot be handled with a single prompt. Think of it like the difference between answering a question and completing a project. Now, let's understand about memory in agentic AI systems. Another critical component is the memory. Without memory, an AI system behaves like a stateless chatbot. Every interaction starts from zero. With memory, agents behave more like assistants. There are different types of memory. Short-term memory, which helps maintain the current conversation context and tracking ongoing steps. Now, the long-term memory stores information across sections like user preferences or historical data, and vector memory uses embedding to retrieve relevant information based on similarity, which enables personalization and context awareness. Memory is what makes AI agents feel intelligent over time. Now, tools to use in agentic AI. One of the most important and powerful capabilities of agentic AI is tool usage. AI agents are not limited to their internal knowledge. They can interact with external systems like APIs, databases, search engines, software applications, and automation platforms. This transforms AI from a system that can actually perform actions. For example, instead of estimating a calculation, an AI agent can call a calculator tool and return the exact same result. This significantly increases reliability and real-time usefulness. Reasoning and feedback loops in agentic AI systems are also operating using iterative. The next one is reasoning and feedback loops. Agentic systems also operate using iterative reasoning cycles. The goal: plan the next action, execute the action, observe the results, evaluate the outcome, adjust the strategy. This continuous feedback loop allows AI agents to correct mistakes, improve performance, and adapt decisions dynamically. Traditional AI produces a single output. Agentic AI continuously improves towards goal. The agentic AI architecture mindset is the most important one. Now comes the AI agent architecture mindset. Most agentic systems follow a modular architecture. You can think of it like components working together. The brain is the language model, the memory stores the context and knowledge, the tools provide external capabilities, the planner decides what to do next, the executioner performs actions, and the evaluator checks the results and provides feedback. This modular approach makes systems scalable, flexible, and powerful. Why these concepts matter? Now you might wonder, why does this all matter? Because these components determine how reliable, safe, and scalable an AI system can be. If you only think in terms of prompts, you will build chatbots. But if you think in terms of autonomy, planning, memory, and tools, you will build intelligent agents. And that's the mindset shift professionals need today. So now you understand the fundamental building blocks of agentic AI, autonomy, planning and memory tools, and reasoning loops. In the next chapter, we will move from concepts to implementation. We will explore the frameworks and libraries that allow to build real agentic systems in practice. And that's where the things start becoming really exciting. Now we enter into the chapter 3, Agentic AI frameworks and libraries. In the previous chapter, you learned the core concept behind agentic AI, autonomy, planning, memory tools, and reasoning. Now, in this chapter, we focus on practical ecosystems that enables developers to build real-world agents. Agentic AI systems are rarely built from scratch. Instead, developers use specialized frameworks and libraries that provide pre-built components for orchestration, tool integration, memory, and execution. The first one, LangChain. So we'll have an overview and architecture. One of the most widely used frameworks for building agentic AI applications is LangChain. LangChain is designed to help developers connect large language models with external tools, APIs, databases, memory systems, application logic. Core idea of LangChain. LangChain acts as a middleware layer between language models, tools, applications. Instead of writing complex orchestration logic manually, LangChain provides modular components that simplify development. Now, let's understand the key components of LangChain architecture. The first one, models. These are the LLMs used for reasoning and generation. These include models from OpenAI, Mistral AI, and LangChain provides wrappers to connect these multiple providers. The next one is prompts. Prompt templates allow structured input formatting. This ensures consistency, reusability, dynamic data injection. The third one is chains. Chains represent sequences of operations. For example, you start from input, then go into processing, and then comes the output. Chains can include multiple prompts, tool calls, logical steps. They are useful for deterministic workflows. Now, the fourth, agents. Agents introduce decision-making capabilities. Instead of predefined sequences, agents decide which tool to use, when to use it, what action to take next. This is where autonomy emerges. Now, the fifth one. Memory modules allow agents to retain context across interactions. For example, conversation memory, summary memory, vector database memory, and a lot more. Now, the sixth one. Tools. Tools are what transform the AI agents into action-capable systems. Now, the second one. Alternatives to LangChain. While LangChain is popular, several other frameworks also exist, each with unique strengths. Now, one of them is AutoGen, developed by Microsoft. AutoGen focuses heavily on multi-agent collaboration. Let's also discuss the key strengths. Agent-to-agent communication, role-based AI systems, conversation-driven workflows, enterprise-friendly design. It is widely used for research and advanced automation scenarios. The other one is Crew AI. Crew AI is designed around the concept of role-based agents working on a team. Some of the features in Crew AI are task delegation between agents, hierarchical workflows, specialized roles such as researcher, writer, analyst, simple configuration. True AI is particularly useful for business automation pipelines. Now, another one is one of the early experimental agent frameworks. It introduced the concept of autonomous task creation, task prioritization, continuous execution loops. Although experimental, it influenced many modern frameworks. Now, the next one is AutoGPT. AutoGPT is another pioneering automation agent project. So let's discuss some of the capabilities. Self-prompting, goal-driven loops, internet interaction, file operations. AutoGPT demonstrated the potential of fully autonomous AI agent systems. Now, the third one, tooling for agent memory, planning, and execution. Building effective agents requires multiple supporting technologies beyond frame. Memory tools. Memory is often implemented using popular vector databases. Popular options include ChromaDB, Pinecone, VV8, FAISS, and these systems store embedding and allow similarity-based retrieval. They enable agents to remember past interactions, retrieve relevant context, maintain long-term knowledge. Now, let's go through the planning tools. Planning tools help agents to break goals into smaller tasks. For example, task decomposition engines, graph-based execution frameworks, workflow automation or workflow orchestration. Modern AI agents framework often include planning modules or integrate with orchestration systems. Execution tools are the next one. Execution involves interacting with external environments. Common integrations include APIs, Python functions, databases, web browsers, automation platforms. Execution layers are critical for turning AI into operational systems. Now, we come into the fourth stage, which is about how LLMs are orchestrated with tools. At the heart of Agentic AI is orchestration. Coordinating LLM's reasoning with external tools, a typical orchestration workflow looks like this. User provides a goal, LLM interprets the objective, agent decides which tool to use, and executes the action. Results return to the LLM, and LLM evaluates and plans the next step. This loop continues until the completion of this task. This creates a closed-loop intelligence system, functioning calling and tool invocation. Modern LLM provides support structured tool interaction through features like function calling, tool schemas, API integrations. This allows agents to move beyond text generation into real-world action execution. Now the fifth one, choosing the right framework. The best framework depends on your goals. Let's see some scenarios. If your use case is about learning and experimentation, then LangChain is your best recommended framework. If you're focusing on multi-agents, then AutoGen could be the best. If you're working on business workflows, then Crew AI could be the best. AutoGPT will be the best for autonomous experimentations, and for concept exploration, Baby AGI would be the best. There is no single best solution. Architecture decisions depend on requirements. Now, let's go through industry trends. From prompts to systems, the industry is shifting from prompt engineering to system engineering. Developers are increasingly designing AI systems composed of multiple components rather than a single model interaction. This trend is driving the demand for professionals skilled in AI orchestration, agent architecture, tool integration, and automation design. Next chapter, we will land into memory and long-term context. That brings us to the next chapter. So this will be all about memory and long-term context. In this chapter, we are going to discuss one of the most important concepts or components of Agentic AI, which is memory. In fact, memory is what truly separates a simple AI assistant from a genuinely intelligent agent. Think about it in this way. If an AI system cannot remember anything about you, your past interactions, or what it did 5 minutes ago, it behaves like a stateless chatbot. But the moment you introduce memory, something powerful happens. The system becomes capable of personalization, context awareness, learning from past actions, and even long-term reasoning. In other words, memory converts AI from reactive intelligence to adaptive intelligence. So in this chapter, we will explore why memory matters, the different types of memory used in agentic AI systems, and how persistent context dramatically improves agent performance. Now, why memory matters in AI agents. AI systems rarely operate in single step. They often execute multi-step workflows, sometimes across multiple sessions or even long time periods. To function effectively, they must remember things like previous conversations. User preferences, task history, intermediate results, and knowledge. When AI agent has memory, it can maintain continuity in conversations, avoid repeating mistakes, improve decisions over time, personalize responses, and execute long-running tasks efficiently. From a systems perspective, memory is what enables an AI agent to evolve instead of starting from zero every time. Now, let's go through types of AI agent memory. Let's talk about different types of memory architectures used in modern agent systems. Each type serves a different purpose. Let's discuss the first one, buffer memory, which is essentially short-term memory. This stores recent interactions temporarily. It helps the agent maintain immediate or intermediate context during a conversation or a workflow. However, it has limitations. It usually has a small size due to a token constraint, and once the session ends, the memory is often cleared. You can think of it like human working memory, the information you hold briefly while solving a problem. Buffer memory is commonly used in chat conversations, step-by-step reasoning tasks, and workflows that require temporary state tracking. The next one is summary memory, and this can be considered as a second type. Instead of storing entire conversations, the system compresses past interactions with shorter summaries. For example, it might store key decisions, important facts, or action outcomes rather than raw text. This approach has major advantages as well. It reduces computational cost, saves tokens, and still preserves essential long-term context. Summary memory becomes essential, especially useful when AI agents run for long durations and accumulate large volumes of information. Now, the third one is vector database memory. It is the most important and powerful type of memory in Agentic AI, and it is also known as long-term memory. This works differently from traditional databases. Instead of storing plain text for keyword research, the system converts text into numerical representation called embedding. These embeddings are stored in a vector database, and when the AI agent needs information, it retrieves relevant data using similarity search based on meaning, not exact words. This allows agents to remember user preferences, retrieve research documents, and recall historical conversations, and also access knowledge accumulated over time. You can think of vector memory as long-term knowledge repository for the agent. Now, the next one is persistent memory with vector databases. To implement long-term memory, AI agents use specialized storage systems called vector databases. Two commonly used solutions are Chroma and Pinecone. Chroma is widely used for local development and experimentation because it is open source, lightweight, and easy to integrate, especially with Python environments. Pinecone, on the other hand, is managed cloud solution designed for production systems. It offers scalability, high performance retrieval, and enterprise level reliability. So depending on whether you are building a prototype or a production application, you might choose different tools. Now the next one is persistent memory workflow. The workflow for persistent memory typically follows a simple pipeline. First, data is generated or received. Then the text is converted into embeddings. Those embeddings are stored in a vector database, and whenever the AI agent needs context, it retrieves the most relevant information. This allows AI agents to remember information indefinitely and use it whenever required. The next one is embeddings, the foundation of vector memory. At the heart of vector memory are the embeddings. Embeddings convert the text into numerical vectors that represent semantic meaning. This means sentences with similar meaning will produce vectors that are mathematically close to each other. For example, phrases like machine learning course or AI training program would likely have similar embeddings, even though the words are different. Embedding models are available from providers such as OpenAI and Hugging Face, and they power many modern AI capabilities. Now let's understand why embeddings are so powerful. Embeddings enable semantic research, context retrieval, knowledge augmentation, personalization, and recommendation systems. They are the core building blocks behind modern intelligent applications. Without embeddings, long-term memory in AI systems would not be nearly as effective as how it is. Now, let us understand how memory improves AI agent performance. So let's talk about practical impact of memory. Memory improves agent performance across multiple dimensions. It enables context awareness. Agents can reference previous interactions and maintain continuity without repeating work. Now, the second one, it enables personalization. AI agents can adapt to individual users, remember preferences, and provide tailored responses. Now, the third one, it improves efficiency and speed. By remembering previous computations, AI agents avoid redundant processing, which reduces cost and latency. And the fourth one, it leads to better decision making. AI agents can learn from past outcomes and avoid errors and define strategies over time. And finally, memory makes long-running autonomous systems possible. Some AI agents operate for hours or even days, tracking workflows and progress across sessions. Without persistent memory, true autonomy simply cannot exist. Now, let's take a look into memory challenges and considerations. Of course, memory systems also introduce challenges. They are storage costs to consider. Retrieval accuracy must be managed carefully. There are privacy and security concerns as well when storing users' data. Agents must filter relevant context effectively, and incorrect or outdated memory can also sometimes lead to hallucinations. So, designing memory architecture requires thoughtful planning as well. Now that you understand how memory allows AI agents to retain context, learn from experience, and improve performance over time, we are ready to move to the next concept. In the next chapter, we will explore planning and decision chains, where AI agents learn how to break down goals and execute complex multi-step behaviors autonomously. And this is where AI agent intelligence becomes even more powerful. Now we come into the next chapter, which is about planning and decision chains. In the previous chapter, we explored how memory enables agents to retain context and learn over time. Now, we are going to discuss another defining capability of agentic AI, which is planning. Planning is what separates a simple AI assistant from a truly intelligent agent. A basic AI model waits for instructions and produces an answer, but an AI agent must figure out how to achieve a goal step by step, often without continuous human guidance. And that's exactly what planning enables. What is planning in AI agents? At its core, planning is a process where an AI agent understands an objective, breaks it into smaller tasks, determines the order of actions, and executes those steps while monitoring progress. Instead of solving problems in a single response, agents operate through an interactive execution loop. A typical planning cycle looks something like this. First, the agent defines the objective. Then it analyzes what is required. Next, it creates a task list. It executes those tasks, evaluates results, and if needed, adjusts the plan. This loop continues until the goal is achieved. Planning allows agents to handle complex workflows, multi-step reasoning problems, and long-running automation tasks that would be impossible with a single prompt. Now let's discuss chain of thought versus tree of thought. Let's talk about reasoning strategies, which are critical for planning. Two important approaches you will often hear about are chain of thought and tree of thought. Chain of thought reasoning. Let's start with chain of thought reasoning. Chain of thought reasoning works through a linear sequence of steps. You can imagine it as moving from step 1 to step 2 to step 3 until reaching the final answer. This approach is relatively simple but efficient. It works well when the path to the solution is predictable, such as a mathematical reasoning or structured logical problems. However, there are limitations. Since the reasoning follows one path, errors can propagate through the chain, and there are no exploration of alternative solutions. So while chain of thought is powerful, it's not always flexible enough for complex decision making. Now we have tree of thought reasoning. So tree of thought reasoning expands the process into multiple possible paths. Instead of committing to one direction, the agent explores different options, evaluates them, and then selects the best one. This approach improves decision quality because it allows comparison between alternatives. It is especially useful for complex planning scenarios where multiple strategies might exist. Tree-based reasoning is actually closer to how humans think when solving strategic problems. Now let's go through the key differences. So the simplest way to understand the difference is this. Chain of thought is linear reasoning. Tree of thought is branching reasoning. And in real world, AI agent systems, both approaches are often combined depending on the complexity of the task. Now, let's go through task decomposition and workflow design for agents. For AI agents to complete complex goals, they must break large objectives into smaller executable components. This process is called task decomposition. Modern agent frameworks allow developers to design workflows that are not just linear, but dynamic systems that can adapt based on conditions. One powerful concept here is graph-based workflows, where tasks are separated and represented as nodes and connected by decision paths. This enables conditional execution, iterative loops, and checkpoints for human approval and even parallel task execution compared to fixed pipelines. Graph-based planning provides much greater flexibility and reliability. Now, let's discuss about implementing multi-step autonomous behavior. So let's take a look at what multi-step autonomy actually means in practice. A typical autonomous workflow might start with a goal being provided to the agent. The AI agent generates a plan, selects the appropriate tool, executes actions, evaluates the results, and updates the plan if necessary. It's the cycle until the objective is complete. For example, imagine the goal is to create a market research report. The agent could automatically search for industry data, extract insights, and analyze competitors, generate the report, and format the output, all with minimal human involvement. This is far more advanced than simply responding to a prompt. It represents the true autonomous execution. Now comes the next phase, planning challenges of agentic AI. Of course, planning is not easy. There are several technical challenges that developers must consider. Agents might break tasks incorrectly, choose the wrong tools, or get stuck in loops. There may also be resource constraints or uncertainty in decision making. To build reliable systems, developers often introduce safeguards such as step limits, validation checks, monitoring mechanisms, and human approval stages. Planning is powerful, but it requires careful design to work safely in production environments. Planning is a core agent capability. Ultimately, planning transforms AI systems from reactive responders to strategic problem solvers. It allows agents to solve complex problems, execute long workflows, adapt to new information, and operate with high degree of autonomy. If memory gives agents experience, planning gives them direction. Together, these capabilities form the foundation of the intelligent AI automation. Now that you understand how AI agents plan and make decisions using structured reasoning chains, we are ready to move into the next stage. In the next chapter, we will explore advanced agentic AI use cases, real world automation scenarios, and that's where you'll start seeing the true power of agentic AI systems. Now we enter the next chapter, which is about advanced use case of agentic AI. So far, we've explored the core building blocks of agentic AI, which are memory, planning, reasoning, and tool integration. Now the big question, where does all this actually get used in the real world? In this chapter, we will look at some advanced use cases where agentic AI systems combine these capabilities to execute complex workflows with minimal human involvement. And this is where agentic AI truly starts to demonstrate its value. One of the most powerful applications of agentic AI is the creation of autonomous research assistants. Unlike traditional tools that simply retrieve information, agentic systems can browse the web, extract the relevant content, compare multiple sources, and generate structured summaries, often with citations. This makes them incredibly useful for scenarios like market research, academic research, competitive analysis, and even content creation. The key advantage here is not just information retrieval, it's continuous reasoning and validation across multiple steps. The agent doesn't find data, it evaluates it. Now, let's dive into multi-agent collaboration or role-based systems. Another advanced concept is multi-agent collaboration. Instead of relying on one agent to do everything, you can design systems where multiple specialized agents work together, similar to human team. Now, frameworks like True AI enable this type of role-based architecture. For example, you might have a research agent that collects data, an analyst agent that processes insights, a writer agent that generates content, and a reviewer agent that validates the final output. This approach improves both quality and scalability because each agent focuses on a specific responsibility. It mirrors how real organizations operate. Now, let's go through automation pipelines like email, research, and summarization. Agentic AI also enables end-to-end automation pipelines. Imagine a system that reads incoming calls, extracts important information, conducts background, generates response, and sends the reply automatically. That entire workflow can run with minimal human supervision. These automation pipelines significantly reduce manual workload and improve productivity across business operations. They are knowledge-based tasks. Now, let's discuss integration with external tools. AI agents become truly powerful when they connect to real world software systems. For example, integrations with platforms like Zapier allow agents to trigger workflows across thousands of applications. Integration with Notion enables knowledge management and documentation updates. And tools like Google Sheets allow agents to store data, generate reports, and maintain structured records. Through these integrations, agents can update databases, synchronize information across platforms, generate analytics, and automate operational processes. This is where AI evolves from being a conversational assistant into an operational automation layer inside organizations. Now that you have seen how agentic AI is applied in advanced real world scenarios, from autonomous research to multi agent collaboration and enterprise automation, the next step is understanding how to measure and improve these systems. Now, in the next chapter, we will focus on evaluation and optimization, where we analyze agent performance and learn how to increase reliability and efficiency. And this is critical for deploying production grade agentic systems and solutions. Now, the next chapter is about agent evaluation and prompt optimization. So far in this course, we have discussed how to design agents, how they plan, how they use memory, and how they interact with tools. But building an AI agent is the only beginning. The real challenge is making that agent reliable, efficient, and production ready. And that's exactly what we are going to do focus in this chapter. Because an AI agent that works once is not enough. We need AI agents that work consistently, measuring agent performance and task success. Now let's dive into measuring agent performance and task success. The first step is improving an AI agent is understanding how well it performs. Agent evaluation focuses on a simple but important question. Did the system achieve its intended goal, and how efficiently did it do it? There are several metrics commonly used to measure performance. For example, We might look at the task completion rate, how often the agent is successfully finishing the task. We might evaluate the accuracy of the outputs, the number of steps taken to search a solution, whether tools were used correctly or not, and how much time or cost is involved in execution. In real world environments, developers often test agents using defined scenarios or benchmark tasks to simulate production conditions. This allows us to identify weaknesses before deployment. Prompt debugging techniques. Now, let's go through prompt debugging techniques. Now, let's talk about one of the most practical skills in Agentic AI, prompt debugging. Prompts act as the instructions that guide an agent's reasoning process. So, if prompts are unclear or poorly structured, the agent will struggle. One effective approach is breaking large prompts into smaller, more specific instructions. Adding constraints and formatting requirements can also improve consistency. Providing examples, what we call as short prompting, often helps the model understand expectations more clearly. Another important technique is explicitly defining the agent's role and objective. And finally, logging intermediate reasoning steps allows developers to see where failures are occurring. In many ways, debugging prompts is very similar to debugging codes. Small changes can produce surprisingly large improvements. Agents can also improve when they receive feedback, and feedback can come from many sources. Users might correct outputs, systems may record whether tasks succeed or fail, there could be ratings, evaluations, or monitoring logs capturing performance data. When this feedback is incorporated into the system, agents can adjust strategies, refine prompts, and reduce errors over time. This creates adaptive systems that continuously improve instead of remaining static. When optimizing AI agents, there are generally two main approaches, prompt engineering and fine tuning. Let's go through prompt engineering. Prompt engineering involves modifying instructions without changing the underlying model. It's faster, cheaper, and effective for most use cases. That's why the majority of agent systems rely heavily on prompt design. Fine tuning, on the other hand, involves training the model on custom databases or datasets. This approach can provide more consistent behavior in specialized domains, but it comes with higher cost and complexity. In practice, developers typically exhaust prompt engineering strategies before moving into fine tuning. Now that you understand how to evaluate agent performance and optimize behavior through prompts and feedback, we are ready to move to the final stage in this course. In the next chapter, we will explore the risks, ethical considerations, and future of agentic AI, including safety challenges, industry trends, and what lies ahead of the intelligent autonomous systems. And this is where we connect technology with responsibility, and we will also be building an AI agent. So now we have reached to the final chapter of this course. So far, you have learned how agentic AI systems work, from core concepts and planning to memory, tools, and real-world applications. But as these systems become more autonomous and powerful, an important question emerges. How do we use this technology responsibly? Because with this greater capability always comes greater responsibility. In this chapter, we will explore the risks, ethical considerations, and the future direction of agentic AI. Now, autonomy versus control. Safety considerations. One of the biggest advantages of agentic AI is autonomy. Agents can make decisions, execute tasks, and complete workflows with minimal human intervention. But this same autonomy also introduces risk. For example, an AI agent might make incorrect decisions based on incomplete information. It could perform unintended actions if instructions are misunderstood. Organizations may become overly dependent on automation. And there can also be a security vulnerability if AI agents interact with external systems without proper safeguards. This is why safe deployment requires strong monitoring, validation mechanisms, and human oversight. Autonomy should never mean lack of control. The goal is controlled autonomy. Alignment and hallucination challenges are the next ones. Two major technical challenges in AI systems are alignment and hallucination. Alignment refers to ensuring that the agent's actions match human intentions and goals. Even a highly capable system can create problems if it optimizes for the wrong objective. When AI generates incorrect or fabricated information while sounding confident. This is especially dangerous in high-stake domains like healthcare, finances, or legal systems. To reduce these risks, developers often implement validation steps, tool-based verification, feedback loops, and human in the loop checkpoints. Reliability is not optional, it is essential for real world adoption. Now, let's go through future trends in agentic AI. Looking ahead, agentic AI is expected to transform how we live and work. One major trend is the rise of personal AI assistants that manage schedules, tasks, and decision making support. Another trend is workplace automation, where AI agents handle repetitive business operations, allow humans to focus on higher value work, and more like it. Likely to see autonomous research systems accelerating scientific discovery by analyzing data and generating hypotheses. And perhaps most importantly, AI collaboration systems will emerge where humans and agents work together as integrated teams. We're also moving from AI as a tool towards AI as a digital workforce. Now, let's go through some final thoughts as well. You have now completed a full journey through agentic AI, starting from fundamentals and moving through architecture, planning, memory, and advanced applications. But learning doesn't stop here. The best way to truly master this field is through hands on experimentation. Build your own agents, integrate them with tools and APIs. You can also explore multi agent collaboration systems, experiment with evaluation and optimization techniques, and practical experience is what transforms knowledge into expertise. Agentic AI represents one of the most important shifts in artificial intelligence. We are moving from passive models that generate responses to autonomous models that are capable of reasoning, planning, and action. And the future will belong to the professionals who will understand not just prompts, but complete AI system design. Now, let's proceed to building an AI agent. So now we will be building an automated email writer or AI agent who sends acknowledgements to the people who request for your appointments. Now that is really simple. Now a couple of platforms. So we will be using N8N and Google's. So we will be needing Google Cloud, Google Sheets, Google Forms, and Gmail. So these are the few ones which we will be needing today. So we will try and take some APIs from these platforms and connect them together. And then we will be writing down a couple of prompts for your AI agent to understand the requirements sent by the people who are looking for appointments, and then we can continue with coding it. So now we have a basic understanding. Let's get started with N8N platform. Let me close all these first. So first we will have to create an N8N platform account and then verify it. So I've already done my verification, and then we will be signing into the Google Cloud and create an account and get started with it as well. So we have our Google account ready, and that's the place where we'll be going through console. And then I've also signed into Google Sheets, and I'll be creating a new Google form as well. So we can start from this particular position by creating a blank form. So once the form has been created successfully, you can name it as, you can give it a custom name such as My Appointments. So this particular form will be shared with each and every, or it will be open for all whoever is looking for appointment. And then you can add a couple of options here like name, phone number, etc., or email ID, especially because we're going to, send out some emails. So it will be a short answer, and it will definitely be a required file unless they write down their name and all the details. We cannot create anything further. So the first thing is name. Next is email, and this should also be required. So based on this input from the user, we will be sending out the email. And next will be their maybe phone number. So we have the phone number that will also be short. This will also be required. You can ignore phone number because we are not making any messages here. Like if we were using some triggers like Telegram, etc., we could have done that. So we are also including date, and we are choosing date format. So make sure the data type is good for all of those, or correct for all of those inputs. So I'll take responses as verified ones only. And you can also share a copy with the people who fill the form if they request for it. And then, yeah, I think that would be all from my end. Now we can also link this particular form to a Google Sheet. So that can be done simply by looking into responses, and you can write down, click on link to sheet. You can give a customized name to your sheet. So I'll name it as My Appointments, the same name that we gave to our previous sheet. or Google form. So the same name can be used here as well. So you can see all of the rows or columns that we have entered here are also taking their shape in the Google Sheet. So before you can also directly publish, or before you publish, you can take some, notes and then try to publish it. Or you can also come back and edit at any time. Now we are back on Anytime platform. So here you can click on the first step. So these are the triggers. So we have a wide variety of triggers. It can be a chat, it can be running evaluation, other ways, on schedule, app event, or you can also trigger manually. But now I want Google Sheet as my trigger. So here you have on row added, on row updated, on row added or updated, all these options. So you can also explore a few more actions here. So create sheet, delete sheet, append, update row in a, or append a row in a sheet, that provide variety of options. You can choose based on your requirement. So for me, if a row is added, it's good enough for me. So here you can see on the sheet, if someone has entered data and that is filled in this particular row, and then that particular entry should be considered, and it should be triggering this particular workflow, and that should be triggering that workflow. So for now I need to add credential. So I don't have any credential as of now. So this is where we have to log into our Gmail accounts and everything. So this will be the mock output. Before you add all the credentials, just take a look at that. Now, to add the credential, you need to have OAuth authentication, or you can sign into Google. So before we get the sign-in functionality enabled here, we need to get the OAuth requirement done by our end. So you need to go to this particular Google Cloud, and then you need to enter into console. So once you enter your console, you can select the project you're working in, or you can also create a new project. So I don't have any projects ready as of now. Yeah, I'm going to create one from scratch. So I need to agree for a few terms and conditions here. So my country, and then a few more details. Yeah, this is where I need to check in, and then agree and continue. There you go. Now I'm ready to create a new project. So here I have all the options. So we will be using APIs and services in the next stage. But before that, we need to create a new project. So select a project, and since I'm creating this for learning purposes, I'll be using no organization. And yeah, I need to create a new project on the basis of no organization. And I can name my project as my appointments or something, the customized name, whichever you prefer. So I'll be writing it as my first project, and then I can just click on create. It's creating in the background. Yeah, create project is done. Now I can select that particular project, and here I have all my, it's my dashboard here, my APIs, cloud platform, project info, resources I'm using, the monitoring and everything. So I'll now dive into APIs and services. I think I was supposed to be in OAuth consent screen. That's the one. So I need to click on that. So once I click on that, I will be having all the requirements that I should be creating. So I need to create two things here. First, clients as well as audiences. So first, let's create a client. Now to create a client, you can just scroll down and click on create client. That's the one. You just need to scroll a little bit to the bottom section. So that's the button. Click on that, get started. So once you get started, you can also give some information about your application. You can also use the same name that you gave to your Google Sheet or Google form. I'll create this as appointment app, a customized name. I need to link an email address. So will this be an internal audience or external audience? I'll be creating this for external audience. So whoever is looking for an appointment, you can share the link. So I'll have the contact information here. So I'll add the contact information of the ID which I used to create this project, and then finish and continue and then create. So your audience are now successfully created. Next, you need to set up some test audience. Just click on that OAuth client. So once your client is created, you can get started with audience. The OAuth is successfully created, and I will be creating this as a web application. You can create for Android, Chrome extension, or anything, but I will create this as a web application. So it is compatible in both mobile and desktop as well. So we need to add the URI. So URI is nothing but your Anytime platform URL here. So instead of the slash T2 DJ everything, the addresses of the project you have, you need to remove that, and rest you can just copy and paste. So now you need to add your URI there. So URI is nothing but the URL that you have on your N8N platform. From workflow, you need to ignore everything after workflow, the slash and all those codes or IDs. Then you just copy HTTP all the way up to uh, workflow, or I think you need to copy it till cloud. So just close this or keep editing. I don't want to edit this particular trigger as of now. Just save it or close it as it is. Just copy the URL and just go back to Google Cloud. Here you can just paste it. Once pasted, you also need to authorize redirect URLs. So you need to write down few codes after this particular slash. I think, yeah, the slash is not required there in the first URI. So here you need to write down rest slash to credential slash callback. So you can just copy paste this particular part, which is rest auth to credential and callback, so that you can have it ready to useful for you when you are trying to create this project or replicate this project. Don't worry, this particular workbook that I'm working on will be linked in the description box below so that you can have direct access to it. And then you are creating this particular, yeah. So your client is successfully created. Now you have the client ID. You can copy paste that somewhere for reference for future, or you can also download it as JSON format. So I'll do both. I'll copy and paste this particular client ID in my notepad, as well as I'll download this as a JSON format. No, I think I opened the wrong app. So yeah, that's the notepad document. So here I will create a new doc and just paste it as client ID. And for safe side, I'll just copy this and paste it as well. Those are one and the same. Now, once the client is created, we can navigate back to N8N, and now we need to connect, add the new credential. OAuth2 is recommended, so OAuth2 is done. So you need to sign in. So select the Google account that you use to create this product, and all the apps that we worked on Google Cloud Console. So that and this particular N8N platform are connected to the same ID, and the connection is now successful. So your trigger is almost ready now. So you can close this. Now we need a couple of more things, right? The sheet that we have used and the columns that we have in our sheet and everything. So far, we just connected, we just created an OAuth. So before that, we need to create the audience, right? So click on the audience, and here you need to publish the ad. And just like we did for the clients, you need to do for audience as well. Before we, create some audience, we need to have some test users, right? So you can give any email ID. So I'll create my other email ID here as the test user. I can also add my own email ID as well. So it will not take eligible accounts. So it's some notification that you can ignore. So for safe side, I'll also use the Gmail ID that I have used to create this project. So we'll be having them both. So save. So you can ignore that warning. We are just doing it for testing status. So we have both the emails. Now back to our N8N platform. And here you can set the mock data. So this is how you'll be receiving input. So here we see that the form inputs that we have, the name, address, and everything, they are not present here. Now I need to choose the document, which is the My Appointment sheet. So yeah, this is the sheet. So this particular sheet should be related. And inside this, we have multiple sheets, right? So from which list do I take the data from? So I need to take the list as form responses one. So this is the first sheet in our sheets application. Just click on that. So here you can see we have form responses, right? That's the one we are selecting here. Let me expand the screen. So we are selecting this particular list. So that's the one we need to select here, so that it understands that I have these columns and I need to extract data from those particular columns. And now you can give the trigger mode as well. So you need to fetch the event. So yeah, so no data has been found, because that's the output we are expecting. We have not entered anything yet. Our form is not published yet, and we have not entered any data. So this was the test connection. So the connection is successful. It is able to understand what's present on the sheet and what's not. So now we need to go back to this particular Google Cloud. We need to activate some APIs. So we need three APIs here. So one is Gmail, another one is Drive and Sheets. So we need to activate them. So you can click on APIs and services. So we need Google Drive API. Just click on it and enable it. It might take a moment. Enable. Now let's give it some time to get it activated. And once this Google Drive API is activated, we need two more, which is Google Sheets API. Just erase Drive and write down Sheets in that particular place. Yeah. So let's give it some time to activate or enable. So next we need Google Sheets. So the Google Drive API is ready. So for Google Sheets, you just erase and replace Drive with Sheets. Yeah, that's the one. Just click on Google Sheets API, and the same, you can just click on enable and the Sheets API will be enabled. Let's give it some time. And now the last one is Google email, or you can also type down Gmail. That's the last API that we need to activate, and then we are good to go. So you need to replace mail in place of Sheets, and automatically you'll find Gmail. That's the one, the first one. Click on Gmail API and enable that as well. Once you're done with all API enable options, you can just go back. So the Google Cloud Console job is now done. So our trigger is also almost fully furnished and done. Now you can publish the first Google form that we created. So I need to give a customized name and manage. Yeah, everyone should have the link and publish. So I'll just copy the link or URL and try to enter some data. I'll open a new Google window. I'll go to a new tab. Just paste that particular link here. Okay, some error, requested URL not found. Did we publish the form? Yeah, it is published. Uh, Let me refresh this and go back and try to check the availability. Yes, it is available to all the people, whoever has the link. Okay, editor review restricted. Anyone with link. Basically, it should not be having editor window, but for just checking purposes, let me also add an email address that I want to access this with. Ravi at organization. Yeah, that's the one I can just click on and done. So I'll provide that directly. Let me check my inbox. Let me refresh. Or did I choose the proper link? Let me go back to my Google Forms. Yeah, this was the link. Still an error. I don't have HTTP there. I think there has been some error. Okay, I think I need to select. Let me click on the share link. No, not this. Correspond email. Yeah, this is the link I was supposed to take up. Not a problem. Now let me open the URL. Yeah, now I have that. Now I can add the details. Okay. Yeah. Record this as this particular email. Now I'll write down my name and I'll also write down the email address. I can click from the recommendations and the phone number. I can just I can write down any random number 9123456789. So the number should be 10 digits. Yeah, that's 10 digits. Now we have the calendar format here. Let me select 27th as my appointment. Now I need a copy of this. So send a copy of responses and done. My responses have been recorded. There you go. So it's the form response. So it sent me one of the responses that I added, but I still did not get the acknowledgement email, right? For that, we need to have another action part here. So we have trigger part. We need to set an action part. So for that, we need to switch back to N8N platform. So you can see my sheet has recorded my input. So my mailing address, my name, my phone number and everything. And now let me go back to N8N platform, close this particular. Before that, we can fetch the data and see how's the output. So this is the output that we got in table form. And this is the schema where you can check all the data types. And this is my JSON format as well. So this is how I wanted my data to be. Now, so far so good. My trigger is set. Let me close this. Now I need to add another action. So for that, just click on that. And here I want an action, which is send an email. So let me type down Gmail. And even for Gmail, we have a lot of actions. So Gmail also has a lot of options. So you can send an email, read an email, etc. So here you can see delete message, get message, mark. So I just want to send a message. So you can click on send message. So Gmail also has a lot of options like send an email, read an email, right? Let's explore those options. So just click on that. So here you can see add label message, delete message, get, reply to a message. So I just want to send a message. So I'll just click on send message. And here you have the backdrop where you need to add a new credential and also hard code all those things like which email to select to send a reply and what message should I send, all those things. So adding a credential is simple. You just need to sign in because we already created O. So just click on sign in with Google, and you can select the email that you used to create this project and or the credentials. So I'll just click on that email, and you can allow anything cloud and everything. Just select all. You can yeah, and then just click on continue and done. So connection is successful. So you can choose if anything should have complete access or not. So I just unchecked on that. So but rest everything is connected, and now resource should be message, and the operation should be sending the message. So you can just drag and drop. So that's the email address that I want to send the message to, and the email type should be HTML. Now we need to add the to or information. So the information will be about the to address or the email address who needs to receive this, and the email type will be HTML. And before that, we also have a subject. So you can write down a custom subject here, acknowledgement about appointment from Simplilearn or something like that, which you feel like. So I'll write it down as appointment acknowledgement. So I'll write it down as acknowledgement regarding your upcoming appointment. And now comes the message part. The message should be first, I'll drag and drop the name of the person who's looking for appointment. So I'll write it down as hi, name. So here you can see on the bottom section, you can already read the results. So I'll have a quick preview of how my email is going to look like. So I'll write down as we are pleased to inform you that your appointment has been approved or confirmed as per your requested date. So I can just simply drag and drop the date for that particular option. Just drag and drop it and done. There you go. Please be available at least 10 minutes before the schedule. And there you go. You can have, we hope you have a great day. And you can also have some signatures below. Let's say thanks and regards, Simplilearn. I think it's done. Now let's scroll down and there are no further options. Now you can just click on execute app and see the trial run. Yeah, so we are executing this step. Node executed successfully. Now let's go back to Gmail and check the responses. So this is not the Gmail. Yeah, this is the one. So I received the acknowledgement. Yeah, you can expand. So there you go. 0 minutes ago, we got the appointment scheduled for us. So here's the response that we wrote. Hi Ravi, we are pleased to inform you that your appointment with Simplilearn has been confirmed to the date we requested for 27th February, and please be available at least 10 minutes before. Yeah, that's the one. And there you go. So now this is good enough. But in case, what if the person who is looking for an appointment looks for a previous date? Let's say we are presently at a current date, but just to check the workflow, he or she might choose to select the previous date if this automation works or not. What if the person looks for a previous date and this automation sends him the confirmation? This shouldn't go that way, right? So for that, you can also try to include some conditions so that it checks if the date is present or not or in the future, and if it is in future, then give the appointment. So for that, you can go with an if condition. So I'll add that if. So if the date is in the future, if it is true, then go with the trigger, which is send an email. And if it is from the past, then keep it as it is or do nothing. So I'll click on send an email. That's the first node. You can just close it. You have an idea already. And if it is from the previous dates, then we have an option called do nothing. So just click on that, and there you go. So this is another, extension of this particular same workflow. So you can just replace it with the trigger, and then you can just continue with the workflow. So if the date is from the past, you can just ignore and go to do nothing. And if it is from the future, then you can check the available calendar. You can also connect calendar to this particular app, and you will be good to go. You can also check the time in real time and dates and everything, so it will be fully operational. Do let us know if you want us to work on that project as well. Now you can go to N8N workflow automation and check some templates as well. So here you have AI, sales, IT operations, marketing, document ops, other support. So you can also go ahead with any of those options. And in case if you're looking for customized or dedicated type of templates like data analytics, you can also look at and type data analytics and click on the search bar,
and then you can have all those templates readily available for you. So these are the templates. You can just click on any one of them and try to get started with them based on your requirement. Do let us know in the comment section below, and also for safe side, let me save this particular workflow and download this so that I can attach this particular workflow in the description box below. I'll save it as my workflow and done. And that brings us to the end.
And with that, we have reached to the end of this session on Agentic AI course for beginners. Should you need any assistance, PPT, GitHub links, or any other resources used in this session, then please feel free to let us know in the comment section below, and our team of experts will be happy to assist you at the earliest. Until next time, thank you for watching and stay tuned for more from Simplilearn.